So I wanted to go over this same tree problem, so Leetcode problem, and it's categorized as easy, but I do feel like a lot of people have different thought processes. So I'm gonna solve this problem in a way that makes it very simple to think about, and then I'll do another solution with kind of the way that it should be written. So the first solution is it makes a lot of sense. The second one, though it makes more sense, but it's more advanced, I would say. And the problem is, we have two trees. So I'll just read the problem. It says, given the root of two binary trees, P and Q, write a function to check if they're the same or not. So we have two trees. We're going to compare 1 1, 2 2, 3 3. If they're the same, cool. So one thing that we learn is you could do DFS or BFS. DFS is super easy. you know a lot of people have learned in order, post order, pre-order, and that's DFS left, example DFS right, and then you pass your um, your tree root. So let's say for the first one, you're checking the left, you're checking the right, blah, blah, blah. So right here, we have more like a base template. We know that if we do DFS, we pass the root, we checked everything in the left, we checked everything in the right, boom, we get an answer. So we already have a template when we really fundamentally think about it. So the first thing is we have a base case, our base case. And our second thing is our DFS implementation. And this is kind of like our skeleton. We're gonna go node by node. So given two roots, then you can be like, oh, let me pass two things. Let me pass P and Q. So this would be P and Q. And then here, let me do my Q to the left, because we're gonna then compare these, and then do Q to the right. And we're gonna compare these. So I feel like that's a really good way to kind of think about it. Like I said, I'm going to give you a way better solution after this, but for now, I feel like for people that are learning data structure, especially trees and tries, and DFS and BFS, this is just a great way to think about it. So when you're doing DFS, you have this root node, this PQ. So how are we going to do comparisons? So here we could do more base cases. So we can say, if if P is null, for example, and Q is not null, well, guess what? Is not the same. So I could do that, and I could do also the reverse. I could do, or if P is not equal to null and Q equals to null, then is not the same. Is same is false. And then here I'm just gonna return, because once it finds that it's not the same, then I'm just gonna return, and I'm gonna make this variable called is false. And let me put that variable as a global. So it's same true. If at any point it finds a difference, then I'm just gonna make it is false. And another case is, obviously, this is the root of the node. So if one of them is null, if at any point in time, since is a pointer, if one of them is pointing to something, the other one is not, obviously they're not the same. But what if they are both pointing? Then we have to check for the value. So I could do if the value of one is not the same of the value of the other one, then obviously the same is not true. else is going to continue going, and it's just going to return is same. And our first base case is, hey, let's just compare the root nodes. If P equals Q, return true. If these, we're going to have, if these two things are the same, return true. Else, let's do DFS and check every single node one by one. This means that the whole tree is the same. And if it's not, then we're just gonna go node by node. And actually, let's just run this and see what we get. So here we do get an error, and I do have p value, so I just want to make sure that what we're passing. So DFS is p, then we have q, we have our base cases. So actually, a base case, if p equals null and q equals null, because they could be null, I'm just going to return. And I think that might help me out. So I have the wrong answer right now. The reason I did this is because at any point these could be null. So I just want to put the case, hey, if one of them is null, if they're both null, just return, so then I don't get an error later on. So let me start from the beginning to see why I'm getting the wrong answer. If P and Q equals the same, then return true. Cool. Then I have a same as true. It goes to my DFS P and Q. Then I make this first base case, this second base case, then this third base case, and then this last base case. And then here, let me do, yes. So the reason is because each time this is running with the different cases, if it was false, it'll probably stay false. So if it's the same, make true. This is the default. And then we're going to run our algorithm. So this is a way that we can think about how we can compare these. But what is the best way to do this, or kind of the advanced way of solving this? Well, think about it. If when we first start here, if P equals null and Q equals null, then they are the same. So we can keep this base case here. And another thing is, let's remove this is same. Another thing that we could do is, if this returns true, if P equals null, or Q equals null, or P.val is not equal to Q.val, I'm going to return false. Return. And the reason is because if this passes, then that means that in this next line, if one of them wasn't null, but the other one, at this point, if P is null, the other one will not be. If Q is null, the other one will not be. Or if they're not the same, then return false. So this is passing and this is passing. And then the last thing I have to do is, since these are really good base cases, I can just do this. Return is same tree, P left, Q left, and is same tree, P right. and we never had to call this DFS. So technically, these base cases, in a sense, are being added here, just in a different logic. It's the same thing. And this is being added just here. So we actually don't really need this. And when I run this solution, it passes. And and that's the thing about also Leetcode, that when you solve these problems, there's different ways of thinking about it. And I always feel like the first solution is the way you should be, is just more logical. But as you get better as a programmer, and then you can start writing things a little bit more condensed. Maybe it's not as logical, but it's more condensed. It makes more sense when you really think about it. And this is, I would say, the more